Eighth grade. So our learning target today is I can convert between scientific notation and standard form. So all of our work today is going to be connecting between those two things. Sometimes standard form gets tricky because sometimes people think of standard form as the notation that we use in later units when we solve for a constant. But our standard form that we're going to actually work through today is standard form in terms of it's the form that it's written in, or the answer. So starting with what is scientific notation. Now, people that deal with really big numbers and really small numbers really like scientific notation. They like being able to write it in a different way, because if you forget a zero, it pretty much messes up the whole problem. A zero in a really big number makes a big difference. We wouldn't want somebody to mess up our bank account unless, it really benefited us. But scientific notation is a way to write very large numbers, huge numbers, and very small numbers in a readable manner. So very large numbers, we miss a zero, super big deal. Very small numbers, we put the decimal in the wrong spot, super big deal. Now, the very small numbers comes up a lot in science class. When we're looking under a microscope, something very microscopically small, bacteria being measured under a microscope, is tiny. So what we do is we rewrite it in a more readable form called scientific notation. That's what we're going to work through today. It is how to convert back and forth between the way we're used to seeing it and then this easier way to read that. So by definition, a scientific notation is a number written with a coefficient of at least 1, but less than 10. So we're going to talk about what that looks like. That has to be between 1 and 10. And you have to be multiplying by a power of 10. Go ahead and get those notes in. So it has to be a number between 1 and 10, and you're multiplying by a power of 10. So as we're taking a look at some scientific notation today, keep in mind that we're going to rewrite very large numbers and very small numbers in a readable manner. That's our goal. So the first digit here, which we call the coefficient, so the word that was coefficient here, the number out front, we've talked about that before in math. This has to be between $1 and $10, the coefficient. So I always like for students to think of it as a bank, and we will only accept between $1 and $10 in the bank. Now it has to be, the key though is it has to be less than 10. It cannot be 10. It has to be less than 10. So we can take $9.99, but we cannot take 10. So it does have to be less than 10, from between $1 and $10 in the bank. Then we have this multiplication by 10, because it says multiply by a power of 10. And the key to the power, or the sign of the power, is if the exponent is positive, it means the number is really large. A really large number because it has a positive exponent. Something really big, like trillions, quadrillions, and things like that, like the amount of money I have. If the exponent is negative, that means the number is super small. It's between 0 and 1. Negative exponents are going to indicate something very small under a microscope. It comes up all the time in science when we're looking under a microscope. We're taking a look at some bacteria, things like that. Maybe you've even seen that in maybe in your germ lab that you did in 7th grade science here. So first of all, scientific to standard. So the form that's on the board right now is called scientific because it has the coefficient as a number between $1 and $10. You might say, well, this looks like just 3.8, but if we put an imaginary placeholder in there, that's really $3.80. And that does meet the criteria of between 1 and 10. Then we're multiplying by a power of 10. Multiplying by a power of 10 out back. So to convert from, this is called scientific notation, to something called standard. Standard is just the answer to that. So basically when we say, well, we are going to multiply by 10 to the 4th power, we're really going to multiply by 10 4 times, times 10, times 10, times 10, times 10. And that is the same thing as multiplication by 10,000. If we multiply $3.80 by 10,000, it's a matter of taking the $3.80, remember I had this imaginary placeholder here, and multiply it by 10,000. I'm going to be moving that decimal 4 places to the right when I do that. Now you could always use your calculator to kind of help you through that, but it's really making that value bigger by 10 4 times. 1, 2, 3, 4. Every time we move a digit, we're multiplying by 10. So that new problem in what we call standard form is 38,000. That's what we call standard form answer, 38,000. So same thing over here. In this first example here, this is called the coefficient. It's really from a number between 1 and 10. That's what makes this scientific. The number between 1 and 10, and we're multiplying by a power of 10. In this particular case, we're taking $4.20, and we're dividing it by 10 3 times, because it's saying -3, which really means make it smaller. Divide by 10, divide by 10, divide by 10. So if we're dividing by 10 3 times, we're making this significantly smaller. Every time we move, it's a division by 10. So we divide by 10, divide by 10, divide by 10. And my new answer becomes 0.0042. 0.0042. When I write that answer is actually what we call standard form. Now, of course, I don't need that 0 at the very end, but this answer is called standard form. It's just the answer. So this was called scientific because it met the criteria of we had $1 to $10 in the bank as the coefficient. We're multiplying by a power of 10. We convert to the answer, which is called standard. In this lesson, we're going to be converting back and forth on every single problem. So just some notes here. What we've noticed in this problem is if the exponent was positive, we move the decimal to the right. The reason why we're doing that is we're making it bigger. And the reason why we're making it bigger is we are multiplying. We're multiplying by 10 that many times, the power number of times. That's why it's going to the right. It's getting bigger. Every number in the power is multiplication by 10 that many times. In that particular case, we multiply by 10 4 times, making it bigger by a significant amount. In this problem, if the exponent was negative, we move the decimal to the left. And the reason why we're moving the decimal to the left is it's making it smaller. And the reason why it's making it smaller is it's division happening every time we see the power. The power here is -3. That means we're dividing by 10 3 times. We were dividing by 10 here, which is making it significantly smaller. So let's try this conversion between scientific and standard. This is in scientific because this is $8.10. We're multiplying by 10 to the power. We call this scientific notation. We want to move it to standard form. Now, standard form is the answer. Now, this is really saying that we want to multiply by 10, by 10, by 10, by 10, and so on 9 times. That should be in your brain thinking, I need to get bigger. This has got to get bigger. $8.10 gets bigger. The only way to make $8.10 bigger is move it to the right 9 places. So we're making it bigger by 1, 2, placeholder, 3, 4, 5, 6, 7, 8, 9, lock it in. So we end up with 0, 0, 0, 0, 0, 0, 0. That's a pretty big number. I would love my bank account to be that big. If I represent it with commas, I have my thousands placed there. 1, 2, 3 thousand, 1, 2, 3 million, 1, 2, 3 billion, right? So we have 8,100,000,000. That's what we call standard form. Standard form is the answer to that. Next problem then. So in this next problem, coefficient has to be $3 between $1 and $10. That's happening. There's my power of 10. We call this scientific notation. We're going to move it to standard form, which is the answer. When I look at this problem, I see that there's a negative exponent. Negative exponent means it's making it smaller because negative really means division by 10 5 times. We're dividing by 10 here because of that negative exponent. That means we're making it super small. I have $3 right now. When I divide $3 by 10, it becomes 30 cents. But I'm doing that 5 times, dividing by 10. So once, twice, 3 times, 4 times, 5 times, lock it in. Placeholders everywhere here. So that $3, when I convert it, it was because of the negative exponent, it becomes 0.00003 is my new answer in standard form. It was that all along, but the scientific notation gave it a negative exponent because it's actually a super small number. All right, two left in this you try section. Now, if you were in class with me right now, in the you try section, I would give you some time to solve, but since it's through the video, you're going to stick with me here. That first number has to be between 1 and 10, called scientific notation. We have to be multiplying by a power of 10, which is scientific notation. We're going to convert to standard form. As we convert to standard form, it means the answer. So we have $4.01 in the bank here. We're going to convert. When we multiply by 10, we're going to multiply by 10 4 times. 4 times there. So we're going to go times 10, times 10, times 10, times 10, which is really the same as multiplying by 10,000, which makes it bigger pretty significantly. So we have 4.01. When we multiply that by 10 4 times, that decimal has to go to the right. That's the only way to make that value bigger by factors of 10. So we're going to go 1, 2, 3, 4, and lock it in. So as we do that, we end up with this as our answer. So if we represent it with a comma here, we have 40,100. 40,100. It would be our answer there. As I continue to solve, we have 7.02 multiplied by 10 to the negative third. This is $7.02 in the bank. We're multiplying by 10 to the negative third. Keep in mind that this is scientific notation because we're doing 1 to 10, multiplying by 10, scientific notation. We're going to convert to standard form again, which is the answer to this. When I say divide by a power of, when I say multiply by a negative power, I'm really meaning divide by 10. 3 times I'm dividing by 10. So if I have $7.02 and I'm dividing by 10, it has to get smaller. By 10, 3 times. By division of 10, once, twice, 3 times. Lock it in. When we lock it in, we have some placeholders there. My new answer in standard form becomes 0.00702. All right. So that is our conversion from what we call scientific notation to standard form, the answer. And now what we're going to do on the next page is we're going to go the exact opposite way. So in the exact opposite way, this is the standard form answer, and we're going to convert to scientific. So what we need here is we need a bank set up, and it has to have between $1 and $10 in it. So I cannot put that number in there, 5,920,000. It will not accept it. So I need to move the decimal. So I'm going to have the decimal here, and I need to move it to a place that the bank will accept. The bank will accept a decimal of $5.92. That is supposed to say 5, so if it doesn't, I'm going to rewrite that. That's $5.92. That works. There's my coefficient of 592. Bank will accept between $1 and $10. When I do that, then I have to adjust the power of that. So I'm going to adjust by 1, 2, 3, 4, 5, 6. Power is 6. Now this is where kids get confused. The kids say, well, I moved left, so the power must be negative. I moved left, so power must be negative. And that actually is not true, because what is happening in this problem, this is a really big number. Therefore, its power has to be positive. It's a big number. It has to have a positive exponent. So there is my answer, 5.92 times 10 to the positive 6th power. This bottom answer here is what's called scientific notation. So in this problem, we went from standard form, the answer, to something called scientific notation. All right, moving on to the next problem here on page 20. On page 20, we have 0.00087. We are going to convert this. Now our job is to get this between a number between 1 and 10 in the bank. That cannot be accepted right now. It's too small. I can't take $0 in the bank. 1 and 10 is the only thing I'll accept, scientific notation. So as I start to move, I recognize that I can accept $8.70 though in the bank, because it has to be between 1 and 10. Notice I put myself a little placeholder here. I added a placeholder so that I had some understanding of what the bank's going to accept. When I do that, I have to adjust the power by 1, 2, 3, 4 places. Now, many kids think because I moved right, it's going to be a positive exponent. But that is not true, because the original problem here was tiny. It was under a microscope. It was negative. We had a negative, super small problem at the beginning. So my answer in scientific notation is this here. That's my answer in scientific notation. Make sure you have a -4 there. And that would be our answer. So we went from something called standard form to something called scientific notation. And we are done. So we have a couple left here. And this says you try. Of course, if you were in class with me right now, I would have you try this problem, but since you're not, we're going to keep on rolling with that. I'm asking you to write this in scientific notation. You have 2 rules. The first rule is the first number has to be a number between 1 and 10. It's called the coefficient. So right now we have 68,400,000,000. Too much. Bank can only take between $1 and $10. Has to be less than 10. We're going to take the decimal, we're going to move it, we're going to lock it in right here, which becomes $6.84. We're multiplying by a power of 10. We need a power here. So we're going to go ahead and, if we move the decimal, we need to adjust it on the power. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now, lots of kids think because we moved left, it's going to be a negative exponent, but that's not necessarily true. We need to look at the original problem. That's a huge number. Huge numbers have positive powers. So my final answer in what we call scientific notation down here, this is my final answer in scientific notation. 6.84 times, you do have to have all of this, 10 to the positive 10th power. Done. Scientific notation. We went from standard form, the answer, to scientific notation. All right, moving on. Next problem, move to from, this is called standard form, the answer. And we're going to move that to something called scientific notation. 2 rules for scientific notation. First rule is you can only have $1 to $10 in the bank, and we're going to multiply by 10 to a power. So as we start to do that, we're going to go ahead and move that decimal. We're going to move it to a place that we can accept it. Right now it's too small. We can't accept $0. We're going to move it 1, 2, 3, 4 places. 7.7, and I'm going to put a placeholder in here so I understand it as $7.70, even though you don't see that on the screen. I count the places again just to make sure that I adjust the power because of the movement there. 1, 2, 3, 4. And because it is a super small number, not because I moved right, because it's a super small number that I started with, it's going to have a negative exponent. So your final answer in scientific notation, and if I'm going too fast, please stop the video, is $7.70 times 10 to the negative 4th power. Recognizing that I put this placeholder in there for my own understanding, you do not have to have that placeholder of 0 in that spot. Okay. As we keep moving here, so we have a couple left for scientific notation, and then we're going to talk about what happens with the calculator. Doing a great job, 8th grade. Stay with this, okay? So we're at the 16-minute mark. Hang in there. Next problem, scientific notation. We have to have a number between 1 and 10 as the coefficient, and we need to multiply by a power of 10. This right now is called standard form. It is the answer we're going to convert to scientific. 2 rules for scientific. You need to have a power of 1 to 10 as the coefficient, and you need to multiply, or the coefficient has to be a number between 1 and 10 in the bank, and we need to multiply by a power of 10, what we've been doing all hour. $4,020 is not going to fit in this bank. It's too big. So I'm going to take the decimal that's sitting there, and I'm going to move it to $4.02. When I do that, I have to adjust the power. So I'm going to adjust the power by 1, 2, 3 places. Now, making a decision on the sign on that power. Lots of kids think, well, I moved left, so it must be negative. That's actually not true. Look at the original problem. 4,000 is a positive exponent. It's bigger than 1, so it has a positive exponent. So in scientific notation, my final answer is $4.02 times 10 to the positive 3rd power. That would be my answer, as I was asked in the directions to rewrite the problem in scientific notation. That is what I did in blue down here. All right, guys, hang in there. Next problem. Our coefficient in scientific notation has to be between $1 and $10, and we have to multiply by a power of 10. The bank can only accept $1 to $10 as the coefficient, so we're going to go ahead and move some things around. I need to move this decimal until a place that the bank can accept, which is right here, $5.02. Bank can take that. It can accept between $1 and $10. When I do that, I have to adjust the power. So I'm going to move it 1, 2, 3, 4, 5, 6 places. Now, many kids think I move right, so it must be a positive exponent. But we have to look at the original problem and say, hey, that's super, super tiny under a microscope. So it has to be negative because it was super tiny to start with. Our answer in scientific notation is $5.02 times 10 to the negative 6th power. We call this scientific notation. All of that highlighted in yellow is my answer in scientific notation. All right, switching gears. So we talked scientific today. We talked standard, the answer. So let's talk about your calculator. Calculator notation works a little bit different. And the reason why the calculators have to make their notation a little bit different is the calculator only has space for 9 to 10 digits on the screen. Therefore, if it exceeds that, the calculator has to adjust to give you some sort of readable answer. Same reason, it needs to give you an answer that's readable when it runs out of screen space. So here's what the calculator displays sometimes. 7.3E5. And that's confusing to kids because they're like, well, what does the E mean? And that's really important that we talk about that in case you're solving a really big problem and you're not quite sure about that E. So 7.3 is the coefficient. Remember, the bank can only accept $1 to $10, so that matches. If you want to put a placeholder in there, you could, but I don't want to over explain this problem. The E really stands for times 10, and we've been doing that all hour. So that's great because it matches the two rules in scientific notation. The first rule is that it only accepts $1 to $10 in the bank as the coefficient. The second rule is you're multiplying by a power of 10. That's represented on the calculator by the E, at least the calculators we're using in class right now. That could change on any other website or any other standardized test, but that is the current way the calculators look on our TI-30s. That 5 represents the power, so that actually is the same as 7.3 times 10 to the 5th power, just like we were just working through, called scientific notation. Now keep in mind, standard form is the answer. We've been working through this all hour. So this is really saying 7.3 times 10 to the 5th power. This 10 to the positive 5th power means we're going to multiply by 10 5 times. If you're multiplying by 10 5 times, that 7.3 should get bigger. It needs to get bigger. When things get bigger, we move them to the right to make them bigger by 1, 2, 3, 4, 5 times because of that power. So we're going to take the decimal, move it times 10, 2, 3, 4, 5, lock it in. So my new answer in standard form is really this answer here. And if I represent commas as the thousands place, that's 730,000. So those are the 3 ways that you'll see things. So we've talked the bottom 2 all hour, scientific and standard, but we also need to talk about how the calculator displays that. So be aware of that. So we're going to try a couple more of how calculators are displaying before we get to the summary. Calculator is going to display this at times. And that may be confusing to you because you don't really know what to do with it. And the reason why it's displaying that is the calculator simply ran out of room. So they have 3.3 as the coefficient. Remember, the coefficient can be a number 1 to 10, so that meets all coefficient rules. We're multiplying by a power of 10. That's that E. That E is representing that multiplication by 10. The power there is -7, so that's scientific notation version. Calculator maybe ran out of room. Although in this particular case, I don't think the calculator would have ran out of room on either one of these that I've done so far, but we're going to talk about it anyway. So standard form is, remember, the answer to that. So what is the answer to that? Well, this is 3.3 times 10 to the -7, which really means divide by 10, divide by 10, divide by 10, and we're going to do that 7 times. What happens when you divide by divide by 10 7 times? It makes the 3.3 smaller. When we make something smaller and divide by 10 7 times, the decimal should be moving to the left. So we're going to divide by 10 once, twice, 3 times, 4 times, 5 times, 6 times, 7 times, lock in the decimal. So we fill those in, that's 1, 2, 3, 4, 5, 6. So our final answer then becomes point. We have 0.00000033. So all of that. It becomes microscopically small, and that's all because it had this negative exponent up here, making it super small. Division by 10 7 times, which is confusing to kids because they see the multiplication sign here. But because of the negative exponent, it's actually turning to division. So let's reverse the order. Let's say this is the answer I got. Worked it out on paper, threw it in my calculator. My calculator is like, whoa, I can't fit all of that on the screen. So what the calculator is going to show us is the calculator is going to show us the scientific notation version. So let's first convert to scientific notation. So to do that, I can only accept $1 to $10 in this bank. Right now I have this gigantic number, so I'm going to take the decimal and I'm going to move it until the calculator can accept it, which becomes $2.50. I'm multiplying by a power of 10 here, and I have to adjust the power when I move the decimal, so that's 3, 6, 9, 12, 15. So the power there is 15. And because I move left, a lot of kids think negative, but this is a super big number. I would love to have that much money. Super big number. And so because of that, it's going to be a positive exponent because it's a big number. Now that's called scientific notation. We have both characteristics. I meet my coefficient of $1 to $10. I'm multiplying by a power of 10. What the calculator is going to say is it's going to keep this same coefficient. It will not have that placeholder there that I like to keep, that placeholder that will drop off. Because calculators are very comfortable with that. And they're going to replace this times 10 with an E, but they're still going to keep the 15. So this is their same version of scientific notation, just in calculator form. 2.5E 15 means 2.5 times 10 to the positive 15th power. All right, if I'm going too fast, go ahead and pause that video, but we're already at the 24-minute mark, so I want to keep on rolling here. For scientific notation over here, I'm giving you this. What the calculator is going to say there is it's going to keep that coefficient the exact same way. It's going to take this times 10, it's going to give it an e. We don't know why it does it. Maybe it means that there's an exponent. E must stand for the exponent's coming. And then it keeps the exponent of negative 10. So that's what your calculator is going to display. It still is in scientific notation. It just looks different than the way we write it in class, so be aware of that. Now, standard form, remember, is the answer to this. So we have 3.12 times 10 to the negative 10th power. That means we're going to divide by 10 times. 10 times. So we're making it super small. I have $3.12 right now. I'm going to divide by 10 times. If I'm dividing by 10, it's making it smaller, and the only way to make something smaller, $3.12, is to move it to the left. So we're going to divide once, twice, 3 times, 4 times, 5 times, 6 times. Uh-oh, I'm going to rewrite this because I am running out of room. I'm going to write it way down here, guys. So we're going to move it 10 times again, division by 10, because it's a negative power up there. Once, twice, 3 times, 4 times, 5 times, 6 times, 7 times, 8 times, 9 times, 10 times. Lock it in. Division by 10 times makes this super, super tiny. My final answer in what we call standard form is this new answer. That decimal over here is now gone. No decimal over there. So my decimal has relocated 10 spots to the left. So let's summarize what we talked about in today's work. We talked about 3 major things: standard form and scientific notation, and then we finished it with the calculator work. So for scientific notation, remember that you have to have $1 to $10 in the bank. Has to be less than 10 though. Make sure that's less than 10. That's called the coefficient. Has to be between 1 and 10. And then our exponent, if positive means that it's really big, negative means it's really small. Okay. So that's our scientific notation work there. And a couple other things just to summarize. Remember that the exponent does not mean how many zeros. Does not mean how many zeros. So be aware of that. The exponent does not mean how many zeros. And there's a third star there. If you want to write kind of your own summary, you can. Otherwise, you can leave that third star blank for today. So your homework on scientific notation and standard form for today's work is to finish all of page 21, which is converting back and forth. Now, there's not a ton of work to show this because you're just moving decimals, but it's on page 21, and then there's a review on page 22. Please remember that you're not just counting zeros. You actually have to be thinking about multiplication by 10 and division by 10 and which way you're moving. Again, homework tonight is to do page 21 and 22. Have a fabulous